September 2011. NASA announces they found a planet with 2 suns. Tatooine made real. Star Wars becomes science fact. The internet explodes with excitement. The scientists? They weren't celebrating. They were staring at numbers that made no sense. Because Kepler 16b wasn't just orbiting 2 stars, it was sitting in a zone where planets can't exist, where formation is impossible, where the math says it should have been destroyed billions of years ago. And nobody could explain why it was still there. Here's the rule every astronomer knew. Binary star systems are gravitational war zones. Too violent, too chaotic. 2 stars locked in orbit, constantly tugging at each other, creating chaos in the space around them. Any planet trying to form gets caught in the crossfire. A disaster. What do you need for a planet to survive? Distance. Sarah Seeger from MIT had done the calculations. The planet must orbit at least 7 times farther from the stars than the stars are from each other. Minimum, no exceptions. Closer than that? The gravitational forces shred it, tear it apart during formation, eject it into interstellar space. This wasn't speculation, this was physics, confirmed by every model. 7 times minimum distance. Then Kepler spotted something strange. 2 stars eclipsing each other every 41 days, standard binary system. But the brightness kept dipping at weird intervals when the stars weren't eclipsing. Something else was there. They ran the numbers on Kepler 16b's orbit. The distance from the binary pair? Half the minimum safe distance. Wait, rewind that. The planet is orbiting at half the distance it needs to survive. It's sitting in a zone that should be gravitationally impossible, where no planet should ever form. Yet there it is, perfectly circular orbit, stable, like it belongs there. That's not unusual. That's a direct violation of planetary mechanics. But here's where it gets worse. They could measure everything with insane precision. The planet transited both stars. The stars eclipsed each other. 3 separate dimming events. Multiple data points from every angle. Laurence Doyle from SETI ran the calculations. The numbers were flawless. Kepler 16b's radius? Known to within 0.3%. Better than any exoplanet ever discovered. Its mass? Perfectly calculated from the gravitational tug on both stars. Its orbital mechanics? Mapped with unprecedented accuracy. The best measured planet outside the solar system, Doyle said. Perfect measurements. Of something that violates the laws we thought governed planet formation. You'd think that precision would help explain it. Give us answers. Instead, it made the problem worse. Because now we knew for certain this planet exists exactly where physics says it can't. So how did it form? Theory 1, it formed farther out, where it was safe, then migrated inward. Except migration through a binary system should be violent. Chaotic. Kepler 16b's orbit is nearly circular. That means whatever brought it inward was gentle, controlled, perfectly executed over millions of years. If planets can migrate like that through binary chaos, our models of how planets move are fundamentally broken. Either way, this shouldn't work. Then the second theory, it formed right where it is. But that's impossible. Binary stars stir the protoplanetary disk, the cloud of dust and gas where planets form. The stirring prevents dust from sticking together. Accretion, the process that builds planets, shouldn't work. Professor Amory Triode said it plainly. Using this standard explanation, it is difficult to understand how circumbinary planets can exist. Every answer generates a bigger problem. And then something happened that made everything stranger. 2014, Kepler 16b stops transiting the dimmer star. 2018, it stops crossing the brighter star. The planet vanishes. The orbital alignment shifted. From Earth's perspective, Kepler 16b no longer passes in front of either sun. The method that discovered it, watching for dips in starlight, can't see it anymore. And it won't come back. Not until 2042. For 24 years, the first confirmed circumbinary planet is invisible to the technique that revolutionized exoplanet science. The best measured planet outside the solar system just disappeared from view. Think about that. We finally prove planets can orbit two suns, measure it with perfect precision, and then it vanishes for a quarter century. But the story doesn't end there, because in 2021, someone tried something nobody thought would work. A team in France points a ground-based telescope at where Kepler 16b should be. They're using the radial velocity method, measuring the wobble a planet's gravity creates in its stars. This method has found hundreds of exoplanets around single stars. For circumbinary planets, everyone said forget it. Two stars, two sets of light spectra. Too much noise. The wobble from a planet would be impossible to detect. They detected it anyway. Confirmed Kepler 16b measured its mass through the gravitational wobble it creates in both stars, using a telescope on the ground. In France, for a fraction of the cost of a space mission, the method that was supposed to fail just proved it works. It's a confirmation that our method works, they said, and it creates an opportunity for us to apply this method now to identify other systems like this. Translation: we just opened a door we thought was locked. Now the implications start cascading. Binary star systems aren't rare. About half of all stars in the galaxy exist in pairs. Half. Yet out of 2,662 exoplanets found by Kepler, only 12 orbit close binary pairs. Not because they're rare, because we weren't looking for them right. The transit method is hard. The radial velocity method didn't work. Except now it does. Laurence Doyle estimated there could be 2 million detectable circumbinary planets in our galaxy. 2 million worlds we've been systematically missing. And here's what makes it shocking. These systems might be better for life than we thought. Kepler 16b sits at the edge of the habitable zone. Too cold for life, surface temperatures around 100 C. Gas giant. No solid surface. But simulations suggest something unsettling. A moon, Earth-sized. Orbiting Kepler 16b, rocky. Atmosphere, liquid water, two suns in the sky. The simulations say it's stable. Detectable down to 0.2 Earth masses. No exomoons have been confirmed yet. But if one exists around Kepler 16b, it would be the first. And it would mean we've been ignoring half the galaxy that could host life. What difference did Kepler 16b make? Broke the 7 times distance rule, exists in a zone where formation is impossible, got measured with perfect precision anyway, vanished for 24 years using the original detection method, got found again using a method that wasn't supposed to work, opened up half the galaxy we'd been ignoring. That's not a discovery. That's a systematic demolition of everything we thought we knew about where planets can exist. And here's what nobody's saying out loud. If Kepler 16b fooled us this badly, existing where it shouldn't, hiding for decades, requiring a broken method to confirm, what else are we missing? Binary systems make up half the stars. We found 12 circumbinary planets out of thousands. The math doesn't add up. Unless there are thousands more we haven't found yet. Thousands of worlds orbiting pairs of stars, sitting in zones we declared impossible, potentially hosting moons in habitable zones we never considered. Kepler 16b's was the first, the best measured, the one that proved it's possible. But it won't be the last, because now we know where to look. Now we know what methods work. Now we know the rules we thought were absolute were just our lack of imagination. The planet that shouldn't exist anywhere just proved that impossible is often code for we haven't looked hard enough. And the universe? It's been hiding these worlds in plain sight all along. If you're here for discoveries that completely rewrite what we thought was possible, hit subscribe. The universe keeps proving our assumptions wrong, and we're just scratching the surface of what's really out there.